Hello everyone, welcome back to the Rust programming tutorials. Last time we started discussing about concurrency, or we were discussing about concurrency in Rust, which is quite complex, not easy, but some of the easy examples makes the understanding easy. Last time we saw about how to communicate between threads using messages, using a channel. So it is multi-producer, single consumer channel. So where multiple producers are there, like multiple threads producing a value and a single receiver receiving the value. So this was one way of communication. So there was a sender and a receiver. So you say transaction.send, and then you send the value and the receiver receives it and processes the values. Today, we are going to look at another way, which was a little bit more primitive way of communicating using mutexes. Now, mutex is also allowed to access data from one thread at a time. Okay, so you have a piece of data, any piece of information, which multiple threads need to have access to. But by definition, mutexes or the data type of mutexes only allow one thread at a time to access its value so that you don't accidentally overwrite the existing value. Mutex stand for mutual exclusion. It's a primitive type to share, or it is useful for protecting the shared data which is needed to be shared among different threads. So in order to access the data in a mutex, the thread must first signal that it wants to acquire the lock. Okay, so it's an indication, acquire the lock in the sense, it's an indication that, okay, I want to use or I want to access the data, this piece of information. It will get its lock only if no other thread is holding the lock, actively holding the lock. Okay. And once it has the lock, it processes the data and then it is supposed to release the lock. So it's quite complex, as you can see, because you need to handle acquiring the lock, which means you're blocked until you acquire the lock, and then once you have done processing, you need to release the lock because then there might be other threads that are waiting to acquire it. So lock is a data structure that indicates which thread is currently holding the lock or having the exclusive access to the data. Therefore, mutex is basically described as guarding the data via the locking system. So you have to remember two rules. Acquire the lock. Before using it, you must attempt to acquire. See, it does not guarantee that the moment you call the lock method, you will get it, because you'll have to wait until other threads have released the lock. And then when you're done with the data that the mutex guards or protects, you must unlock. Okay, so here is a simple example. So you have the mutex here in the package sync. What you do is, now here what is happening is this M is the data that is being guarded by this mutex. Just an integer, you're assigning the value 5. This is a single threaded application, so it doesn't matter, but it's just an example of how to create a mutex. So it's mutex : new, like we have seen from other Rust structures, packages, how you create. And see here, how do you indicate that you want to acquire the lock? You call the lock method. Okay, and it gives unlock because it returns a result. Okay, result in the sense if you have acquired the lock or you are unsuccessfully acquired the lock. That's why it returns a result, which is an enum, and you call unwrap to access the value of the enum. So you assign that data M, which is getting to an another mutable variable. You can change the value and see it. We'll see this in example. Okay, so again, how do you create it? You say mutex new to create a data which you want to protect it in multi-threaded environment. That data, you say lock, you tend to acquire the lock before you update it. Okay, some more concepts. Atomic reference counting, okay, ARC. So atomic references provide primitive shared memory communication between data. It's a primitive way of communicating using shared memory and are building blocks of other concurrent types. By default, atomic variables are safe to share between threads because they implement sync. And the compiler itself implements the sync or provides the implementation of the syncs. The compiler provides, therefore, the atomic, they themselves do not provide mechanism for sharing following the Rust model, threading model. The most common way to share an atomic variable is to put it in an arc. Again, we'll see one example, an atomically referenced counted shared pointer. Okay, so our ARC is nothing but atomically referenced counted shared pointer. So you count it. Another concept is poisoning. So what happens if the thread which has acquired the lock on the data for some reason throws an error or panics? Now, every other thread which was waiting on to acquire a lock on that piece of data or that thread, because the thread panicked, right? The thread is that it need not release the lock. So all the other threads are now just waiting. So a mutex is considered poisoned when a thread panics while holding the mutex. Once a mutex is poisoned, all the other threads are unable to access the data by default because it might be likely tainted. A poison mutex, but again, there is a, what do you say, workaround. Does not prevent all access to underlying data. See, the poison error type, okay, when the thread is poisoned, has a type into inner method. So poison error type has a method into inner, which will return the guard that would have otherwise been returned on a successful thing. So guard is nothing but the data. This allows access to the data despite the lock being poisoned. So just this is the next one is an example of arc and mutex. So see, you enclose the mutex into the arc, assign it to a value, you create a channel. Now here see one interesting concept, the for loop. It's just an underscore. Now Rust allows you to do that in case if you do not want to use this value inside the loop. Okay, it's just for an iteration. Okay, for I in 0 to n, but you don't have any usage of I in here. So you don't need to even define I here. So that Rust does not complain about a variable not being used. Okay, so this is just an underscore. Another thing which we hadn't covered before. So you iterate 10 times because n is initialized to 10. You clone the data. You clone the transaction and you pass it to the thread. You move it to the thread. Okay. And then see here, you're trying to acquire the lock on this data. Just nothing, it does nothing, but you could do any kind of processing. Okay. And then you send and unwrap. Okay. So you're going to wait until it becomes 10. And once it is 10, it's going to send and this is going to unwrap. And the lock is unlocked here when the data goes out of scope. Okay. This was a simple example how you can use channels along with thread, along with mutex and atomic reference. Now let's see some action. So I am going to show you first a very simple example, single threaded example, where you create a data using mutex. Define what you do, go inside, you try to acquire the lock, you unwrap it, and then just change the value and print it. Very simple. Nothing fancy about it. So let's see it in action. Cargo run. And see here, it is 6. And it says poisoned false, which means it's not poisoned. The mutex is not poisoned. The status of the mutex, it's not poisoned because it was released, right? Cool. That was very simple, nothing fancy. Let's see another example using multi-thread. Here again, we're using atomic reference and a mutex. See, for this, you're cloning the counter, doing nothing but just +1 here. Okay, so it should print, I think 10 because we start with 0, we iterate 10 times every time we add 1, nothing fancy, but need to know is how to use arc, clone, mutex. These are certain examples that you need to do. Okay, in multi-threaded, you clone you clone the mutex variable and send it to the thread. Okay, here it is. You create or define another variable, mutable variable, and assign it the value that this counter returns, and you just to add 1 and everything. Wait until all join means you wait until all the threads are finished, and then just you print the value, right? So let's see. Oops, re-imported here. Oh, sorry, I did not comment this out. All right, see here, first it's 10. So that was it. So this was a small example. We covered some concepts, which are atomic, what is atomic reference count, what is mutex, how to use it with channel in a multi-threaded environment. You will need to acquire a log, give an indication that you need to acquire a log. It will put the current thread into waiting state until all the other threads, until the other thread which is holding the log releases the log. Okay, so this was all about concurrency in Rust. Go ahead and try from the website, different examples, lots of examples over there. Try and run it for yourself. All right. Thank you so much for your time. See you all again in the next lecture. And until then, keep trusting. Bye.